Did you know that you literally live alongside dinosaurs every single day? I'm not joking. That little bird singing outside your window in the morning, the pigeons you see in the park, even the chicken you ate yesterday, they are all dinosaurs. And in this video, I'm going to prove why science is 100% certain of this. I know it sounds crazy, but stick with me. The idea that dinosaurs went extinct 66 million years ago is technically incorrect. What actually happened is that most dinosaurs went extinct, but one specific group survived, evolved, and became the more than 10,000 species of birds that exist today. And no, this isn't some internet conspiracy theory. This has been scientific consensus for decades. Birds are literally modern dinosaurs. Just as much dinosaurs as T-Rex or Velociraptor ever were. In fact, speaking strictly in technical terms, birds are the most diverse group of dinosaurs that has ever existed. There are more species of birds alive today than all known species of non-avian dinosaurs combined in the fossil record. Get ready, because after watching this video, you'll never look at a chicken the same way again. But before we begin, let me know in the comments where you're watching from and whether you already knew that birds are dinosaurs. And if you enjoy this kind of scientific content, subscribe and turn on the notification bell, because I have many more mind-blowing videos like this one. The discovery that changed everything. The story begins in 1869, just 10 years after Darwin published On the Origin of Species. A scientist named Thomas Huxley was studying an extraordinary fossil called Archaeopteryx, which means ancient bird. This animal was incredibly strange. It had feathers and wings like a bird, but it also had sharp teeth, a long bony tail made of vertebrae, and claws on its wings. It was literally a mix between a dinosaur and a modern bird. Huxley was ahead of his time. He proposed that birds evolved directly from dinosaurs, but his ideas were far too radical for the scientific community of the era. Most scientists believed that birds and dinosaurs shared a very ancient common ancestor, but were otherwise completely separate groups. It would take another 100 years before the scientific world finally recognized that Huxley was right. Everything changed in 1996 with the description of Sinosauropteryx discovered in China. It was the first confirmed non-avian dinosaur found with feathers. These weren't complex modern feathers, but simple hair-like structures. Still, they were unmistakably feathers. What made the discovery even more astonishing was the exceptional preservation. Scientists were able to analyze melanosomes, the cells responsible for pigmentation, and determine the animal's actual coloration in life. The result was incredible. It was red and white, with ringed patterns on its tail and a dark mask on its face. Think about that. For the first time in history, we knew the exact color of a dinosaur that lived 125 million years ago. That discovery changed everything. Since then, dozens of feathered dinosaur species have been found with remarkable preservation. Microraptor was black, with an iridescent sheen like a crow. Anchiornis was black with red highlights and white patches on its wings. Psittacosaurus, a distant relative of Triceratops, was beige with dark spots and a darker face. These discoveries completely shattered the classic image of dinosaurs as scaly reptilian creatures. Many dinosaurs, especially bipedal carnivorous theropods, were covered in feathers. And this naturally leads to the question everyone asks: did T-Rex have feathers? The answer is complicated. Tyrannosaurus rex belongs to the Tyrannosaur group, which is part of the Coelurosaurs, the same major group that includes all birds. This means T-Rex is more closely related to a sparrow than it is to Spinosaurus or Giganotosaurus. Some smaller, more primitive tyrannosaurs did have a covering of simple feathers, particularly when they were young. However, skin impressions from adult T-Rex specimens show scales, not feathers. The most likely explanation is that giant tyrannosaurs lost their feathers as they grew, much like elephants and rhinos lost most of their body hair. When you're that large, overheating becomes a much bigger problem than staying warm, so feathers stop being useful. But imagine this: a baby T-Rex was probably fluffy and covered in down. That certainly changes the image we got from Jurassic Park, doesn't it? A journey to the Triassic, where it all began. Now let's travel 250 million years into the past to the beginning of the Mesozoic era, the famous Age of Dinosaurs. But here's the twist: there are no dinosaurs yet. The planet has just gone through the worst mass extinction in Earth's history. It's estimated that more than 80% of all species disappeared during what we call the Great Dying, at the boundary between the Permian and the Triassic. The planet was, quite literally, a hellscape. All continents were fused into a single supercontinent called Pangaea, turning the interior into a vast, arid desert. Life clung to the coastlines and a few wetter regions. The first animals to repopulate the planet weren't dinosaurs, but strange reptiles and cynodonts. Creatures closer to mammals than to reptiles. The first dinosaurs appeared near the end of the Triassic, around 230 million years ago. They were small, bipedal, and agile. The common ancestor of all dinosaurs probably measured no more than a meter in length. Picture something about the size of a medium dog, walking on two legs, with short but functional arms and a long tail for balance. These early dinosaurs already possessed two features that would later become essential for birds. First, pneumatic bones. Bones filled with air spaces, incredibly light yet strong. This is the same system seen in modern birds, allowing them to fly without excessive weight. Second, air sacs, extensions of the respiratory system that enabled a one-way flow of air, far more efficient than the lungs of mammals. These adaptations gave dinosaurs a massive advantage. They could be more active, faster, and regulate their body temperature more effectively. They were the elite endurance athletes of the prehistoric world. While other animals tired quickly, dinosaurs could stay active for long periods of time. And this is crucial. These traits evolved millions of years before flight ever existed. They didn't evolve for flying. They evolved to make better runners and hunters. Then came the Carnian pluvial event, about 232 million years ago. Essentially, it rained non-stop for over 1 million years. Yes, 1 million years of rain. This completely transformed the planet. Deserts turned into lush forests. The animals that had previously dominated couldn't adapt and went extinct. Dinosaurs, already equipped with superior respiratory and metabolic systems, seized the opportunity and spread across the globe. By the end of the Triassic, dinosaurs had diversified into several major groups. The Saurischeans split into two main branches: the sauropods, which would become the long-necked giants like Brachiosaurus, and the theropods, the bipedal carnivores. It's within this second branch that birds would eventually emerge. Theropods retained a bipedal, agile body plan with functional arms. In fact, if you compare the silhouette of a theropod to that of an ostrich, the similarity is striking. The Jurassic, when feathers took over the world. Welcome to the Jurassic, a period that lasted from about 201 to 145 million years ago. This is the era everyone knows from the movies, and for good reason. This is when dinosaurs truly ruled the planet. But what films rarely show is that many of these dinosaurs were covered in feathers. During the Middle and Late Jurassic, a special group emerged within the theropods called the Coelurosaurs. These dinosaurs were generally smaller and more agile than their larger relatives like Allosaurus. And here's the key point. They developed keratin structures growing out of their skin. At first, these were simple, hair-like filaments. Over time, they evolved into complex feathers. A modern feather is a masterpiece of biological engineering. It has a hollow central shaft called the rachis, from which barbs extend, and those barbs branch into barbules equipped with tiny hooks that interlock. This creates a surface that is flat, lightweight, strong, and flexible all at once. But feathers didn't start out that way. The earliest proto-feathers were nothing more than stiff, hair-like filaments. Now comes the part many people misunderstand. Feathers did not evolve for flight. This is critically important. Feathers came first, and flight arrived millions of years later. So what were feathers originally for? Primarily three things: thermoregulation, display, and nest protection. Thermoregulation is straightforward. Feathers are excellent thermal insulators. They help retain body heat during cold nights and protect from solar radiation during the day. It's the same reason mammals evolved fur. Display is just as important. Many animals use elaborate structures to attract mates or intimidate rivals. Think of a peacock's tail or a lion's mane. Brightly colored feathers served exactly that purpose, and we have direct fossil evidence for this. Oviraptorosaurs, a group of feathered dinosaurs, have been found preserved literally sitting on their nests with their arms spread out, exactly like a brooding hen. These dinosaurs had wings with large fan-shaped feathers, yet they were clearly incapable of flight. They were too heavy, and their bones lacked the necessary adaptations. Those wings were used to protect eggs from cold, rain, and predators. Within the Coelurosaurs, an even more specialized group evolved, the Maniraptors. The name means hand snatchers, referring to their long, powerful arms and highly mobile hands. They had a special wrist bone, the semilunate carpal, that allowed their hands to fold inward and outward, the same motion birds use today to flap their wings. At the time, however, this feature helped them grip prey more effectively. Maniraptors include some of the most famous and fascinating dinosaurs. On one end were the therizinosaurs, gigantic herbivores with the longest claws ever known, exceeding 1 meter in length. On the other end were smaller, agile groups adapted to life in trees. One of these groups, the Paravians, would play a crucial role in the origin of birds. Paravians were small dinosaurs, typically about the size of a cat or small dog, that lived in trees. They had curved claws ideal for climbing, long tails that acted as balancing poles, and complex feathers on their arms and tails. One of the most astonishing was Yiqi, a Chinese dinosaur that lived around 160 million years ago. This animal evolved skin membranes stretched between extremely elongated fingers, creating wings similar to those of bats. It was an arboreal glider, leaping from tree to tree using these membranous wings. Unfortunately, its lineage died out quickly, but it shows just how experimental dinosaur evolution was when it came to flight. Other Paravians retained feathers and began developing increasingly aerodynamic wings. Microraptor, for example, had 4 wings, one pair on its arms and another on its hind legs. It was black, with an iridescent sheen, and likely spent most of its time in trees, gliding from branch to branch while hunting insects and small vertebrates. The first birds and the Cretaceous. We finally arrive at the group Avialae, which includes all birds and their closest relatives. This is where things become truly fascinating, because we are witnessing the transition from tree-dwelling dinosaurs to genuine flying animals. The most famous member of this group is undoubtedly Archaeopteryx, the ancient bird studied by Thomas Huxley. It lived about 150 million years ago in what is now Germany. Roughly the size of a pigeon, it had asymmetrical flight feathers on its wings, a clear sign of aerodynamic adaptation, but it also retained many dinosaur traits: sharp teeth, a long bony tail made of vertebrae, and claws on its wings. For a long time, Archaeopteryx was thought to be the very first bird, but we now know that other flying or gliding dinosaurs existed at the same time. Anchiornis, for example, is slightly older. It was black with red markings on its head and white patches with black tips on its wings. Like Microraptor, it had 4 wings and was probably a fairly capable glider. This brings us to one of the most fascinating debates in evolutionary biology. How did flight begin? There are 2 main hypotheses. The ground-up model suggests that dinosaurs ran while flapping their feathered arms until they generated enough lift to take off. The trees-down model proposes that they were climbers that leapt from tree to tree, gliding farther and farther until powered flight evolved. The most recent evidence strongly favors the second hypothesis. Most early avialae were clearly arboreal, with strongly curved claws ideal for climbing. They lacked the massive chest muscles required for sustained flapping flight, which suggests they were primarily gliders that occasionally flapped their wings to gain height or maneuver. True powered flight would come later. Now we enter the Cretaceous, the final period of the Mesozoic era, which lasted from about 145 to 66 million years ago. This is where birds truly take off, literally. A group called Ornithothoraces appears, meaning bird chest, an incredibly fitting name because they evolved a crucial feature, an enlarged sternal keel. The keel is the large ridge of bone running down the center of the chest in modern birds. If you've ever prepared a whole chicken, it's that large V-shaped bone in the breast. It serves as the anchor point for the massive pectoral muscles required for flight. Without a keel, there simply isn't enough space for muscles powerful enough to sustain flapping flight. With a keel, true, continuous powered flight becomes possible. Ornithothoraces split into 2 major groups: the enantiorniths, or opposite birds, and the euornithes, the true birds. And here's the astonishing part. For most of the Cretaceous, the enantiorniths completely dominated. There were hundreds of species, occupying nearly every available arboreal niche. Some had teeth, others didn't. Some were sparrow-sized, others crow-sized. They were the most successful birds of the Mesozoic. Meanwhile, the euornithes, the group that includes all modern birds, were relatively rare and not very diverse. And here's the curious detail. Most Cretaceous euornithes lived near water. They were aquatic or semi-aquatic birds that fed on fish, aquatic invertebrates, and plants. Ichthyornis, for example, looked like a gull but had teeth. Hesperornis had completely lost the ability to fly and became a specialized diver, using its webbed feet to propel itself underwater like a modern penguin. Why did euornithes specialize in aquatic environments? Most likely because of competition. Enantiornithes dominated trees and forest canopies, while pterosaurs, close relatives of dinosaurs but not dinosaurs themselves, ruled the open skies. By the late Cretaceous, pterosaurs had reached truly monstrous sizes. Quetzalcoatlus, the largest flying animal of all time, had a wingspan of around 14 meters, comparable to a small airplane. As a result, Euornithes found refuge in aquatic niches where competition was lower. At the time, this may have seemed limiting, but it would ultimately save them. By the end of the Cretaceous, modern birds already existed within all three major lineages: Paleognaths, ancestors of ostriches and kiwis; Galoanceriforms, ancestors of ducks and chickens; and Neoavians, nearly everything else. Some of these birds were virtually indistinguishable from modern species. And here's the mind-blowing fact. These birds lived alongside dinosaurs like Tyrannosaurus rex and Triceratops. Birds did not evolve after the dinosaurs went extinct. They evolved during the age of dinosaurs and coexisted with them for tens of millions of years. Birds are simply another kind of dinosaur, one that happened to be in the right place at the right time. The day that changed everything. 66 million years ago, an asteroid roughly 10 kilometers in diameter slammed into the Yucatan Peninsula in what is now Mexico, traveling at more than 40,000 kilometers per hour. The explosion was beyond comprehension, releasing energy equivalent to billions of atomic bombs. The impact vaporized rock, carved out a crater 180 kilometers wide, and hurled trillions of tons of debris into the atmosphere. What followed was a global ecological apocalypse. Worldwide wildfires swept across the planet, incinerating forests. A thick cloud of dust and ash shrouded the sky for years, blocking sunlight. Photosynthesis collapsed. Plants died. Herbivores died. Carnivores died. Food chains disintegrated. It is estimated that more than 75% of all species on Earth vanished. All non-avian dinosaurs went extinct. The massive sauropods, the mighty tyrannosaurs, the swift raptors, every one of them disappeared. Pterosaurs, which had ruled the skies for 150 million years, were wiped out completely. Many groups of mammals, reptiles, amphibians, and fish also vanished. But not everything died. Crocodiles and turtles managed to survive, likely because they could endure long periods without food. Some small mammals that lived in burrows also made it through. And crucially, some birds survived. But not just any birds. The Enantiorniths, the dominant birds of the Cretaceous, were completely wiped out. Not a single species survived. Why? Because they lived in trees, and forests were among the hardest hit ecosystems. With no trees, no fruit, and no insects in the canopy, Enantiornithis had no chance. In contrast, the Euornithes, the relatively modest birds that lived near rivers and lakes, had a crucial advantage. Freshwater ecosystems were among the least affected by the extinction. While forests depend almost entirely on photosynthesis, rivers and lakes derive much of their energy from the decomposition of organic matter. Fungi and bacteria continued breaking down dead plants and animals, sustaining food webs even in darkness. As a result, birds that fed on fish, aquatic invertebrates, and carrion managed to survive. It wasn't easy, but they endured. And when the dust finally settled, the skies cleared, and life began to recover, these birds found themselves in a completely new world. A world without Enantiornithis, without pterosaurs, without giant predatory dinosaurs. A world full of empty ecological niches waiting to be filled. And birds wasted no time. The age of dinosaurs never ended. During the first few million years after the extinction, a period known as the Paleocene, mammals began to diversify and increase in size. But they weren't alone. Birds also underwent an explosive radiation, filling niches once occupied by other dinosaurs. In South America, the so-called terror birds, or Forus racids, emerged. These were gigantic predators that could reach up to 3 meters in height and weigh over 100 kilograms. They had enormous axe-like beaks that they used to strike and dismember their prey. They were, in essence, the new raptors of the Cenozoic. They dominated South America as apex predators for millions of years, until about 2 million years ago, when the continent connected to North America and larger mammalian carnivores, such as big cats, arrived. In Europe and North America, Gastornis appeared, a massive bear-sized herbivorous bird that fed on plants and seeds using its enormous beak. In Australia, Dromornithids evolved into similarly gigantic birds, some weighing up to half a ton. Giant penguins as tall as adult humans patrolled the southern oceans. Pelagornis, a sea bird related to ducks and chickens, had a wingspan exceeding 6 meters and pseudo-teeth along its beak for catching fish. But these giants are only the tip of the iceberg. The true explosion of diversity occurred among smaller birds. During the Eocene and Oligocene, between 56 and 23 million years ago, nearly all modern bird orders emerged and diversified. Songbirds, parrots, owls, eagles, hummingbirds, ducks, pigeons, virtually all of them appeared during this time. Hummingbirds are especially fascinating. They are endemic to the Americas, meaning they exist nowhere else on Earth. They evolved the most sophisticated flight abilities of any vertebrate, capable of flying backward, sideways, and hovering in place with astonishing precision. This allowed them to exploit the role of pollinators, a niche previously dominated by insects. The bee hummingbird of Cuba is one of the smallest dinosaurs that has ever existed, measuring just 5 centimeters in length. At the opposite extreme stands the African ostrich, the largest living dinosaur. It can weigh up to 130 kilograms and reach nearly 3 meters in height. It can run at speeds of up to 70 kilometers per hour and is, in fact, the most dangerous bird on the planet, killing several people each year with its powerful kicks. Today, there are more than 10,000 species of birds, compared to roughly 6,000 species of mammals. Birds are the most diverse group of terrestrial vertebrates. They have conquered virtually every environment on Earth, from the driest deserts to the polar regions, from the depths of the oceans to the summits of the highest mountains. Some birds spend years without ever touching land, flying continuously over the open ocean. Others dive to depths exceeding 500 meters. Some migrate from pole to pole every year, traveling more than 70,000 kilometers. And most importantly, birds are everywhere. That sparrow on your windowsill, that pigeon in the park, that hawk soaring above the city, they are all dinosaurs. Dinosaurs did not go extinct. They simply evolved, adapted, and conquered the world in a way that even Tyrannosaurus rex could never have imagined. When you look at a bird, you are not seeing a distant descendant of dinosaurs. You are looking at a real, living dinosaur, breathing, moving, and carrying all the adaptations its ancestors developed over more than 230 million years. The pneumatic bones that gave theropods their agility, the air sacs that allowed sauropods to reach colossal sizes, the feathers that originally evolved for insulation and display. It's all there, in that small bird singing every morning. The next time you see a chicken, remember that you're looking at a domesticated dinosaur, a direct descendant of creatures that ruled the planet for 165 million years. A survivor of mass extinctions, extreme climate change, and the fiercest competition imaginable. Birds are dinosaurs, and the age of dinosaurs never ended. It simply evolved. So the next time someone tells you that dinosaurs went extinct, you can confidently correct them. Dinosaurs are more alive than ever, singing in trees, swimming in oceans, and yes, even sitting on your plate in the form of chicken nuggets. The story of birds is a story of resilience, adaptation, and evolutionary success. It proves that evolution has no plan, no goal, only survival. And birds, these incredible modern dinosaurs, are absolute masters of survival. I hope this video blew your mind as much as it did mine while researching it. If you enjoyed it, leave a like, share it with friends who need to know that dinosaurs are still alive, and subscribe for more mind-blowing science content. See you in the next video, and in the meantime, go outside and observe some dinosaurs. They're everywhere.